And the question is, are there concentric rings as lensing effects? That's what my eyes see, and if so, why are there multiple rings? Yes, the answer is yes, absolutely. And the reason we have those lens segments is because the cluster of galaxies is a large mass. And any large mass bends light that passes nearby, and it bends light in a way that's very similar to a lens in optics. The image of the more distant object, in this case the more distant galaxy, is magnified. And so that's why we're able to see those more distant galaxies using the wonderful natural gravitational lens of the cluster. And again, that's because of the large mass of the cluster. If we have a situation where we're off over here and this is a cluster of galaxies between us and a distant galaxy, the light from the distant galaxy passes nearby the cluster and it gets bent around the cluster as it travels. Then we, over here, detect that light and we see the lensed image of the more distant galaxy, in addition to the cluster of galaxies, just as we saw on that James Webb Space Telescope image. The type of image that we see depends on the geometry. So, if the distant galaxy is not lined up at all, then the light from that distant galaxy just travels through space and it's not affected at all by the cluster of galaxies. On the other hand, if the distant galaxy is lined up perfectly, that is, between us as the observer, the cluster, the lens, and the distant galaxy, if the alignment is perfect, then the image that we see on Earth is what's called an Einstein ring. And it's a perfectly circular ring of light that comes from that distant lensed galaxy. If the alignment is slightly off from perfect, we won't see a perfect Einstein ring, but rather we'll see little segments along that ring for any particular object. And that's what we saw in the James Webb Space Telescope image. We see the little arcs of lensed distant galaxies. So yes, that is a lens effect, and it's absolutely caused by the gravitational lens of the cluster, the intervening cluster of galaxies. Another question asked whether we could get multiple images of that distant galaxy. And yes, that's possible as well. Again, depending on alignment, we might have light passing the cluster of galaxies in this orientation and more or less simultaneously passing on the other side, so that we on Earth see two arcs of image, lensed image of the distant galaxy that is the same galaxy. And absolutely this is possible, and we observe this all the time in these lensed images. The question was whether there was enough time delay between those two light travel paths as they passed by the cluster, one side and the other side, whether there's enough time, billions of years, that would allow us to see the distant galaxy at different stages in its history. And the short answer to that is that we might see the distant galaxy at different times because the light travel time of those two paths might be different, but they're not going to be different by billions of years. We might have a couple of days, light days, of difference in travel time. And sure, we can look at those two images and see if there's been any change on that time frame, but it's not going to be billions of years. We can use that, however, to study the more distant object in a better and different way, just not in a way that shows us significant change over a significant period of time.